how this goes. Make sure my volume's properly set up. Make sure the game volume isn't too loud, or the music, I should say. Alright. Close out Discord. Alright, so I've played a little bit of this game, so I'm not completely blind to it, but felt like it's better than me going through and learning every single little bit about it while I'm playing, because that might be a little boring to watch. So, I did not mean to leave this here. Alright. Active and network are simple outputs connected to LEDs. Control the active and network outputs with fixed repeating signals as indicated in the verification tab. So, 2, 3, 4, sleep 6 goes up and outputs 100 for 1, 2, 3, 4, 5, 6. So that's for the active network. Or the active signal, I should say. Get rid of the comments. So I believe the top one already works properly. Yeah, it does. Okay. So the bottom one I need to do by myself, so it's gonna be, looks like just 4. It's gonna sleep, or first it's going to move 0, sleep 4, move 100 to P0, sleep 4, I believe 2, move 0, sleep 1, 100, 0, sleep 1. I believe that should be it. Yep. Appears to be it. Lines of code. I'm sure there's other ways to make the code shorter. Doesn't seem to be in cycle with the top one, so I guess you couldn't really do anything that would rely on that. I don't know. I can come back to that one if I ever have any better ideas for it. The volume a little bit, make sure it's not too loud. Okay. Control in is a simple input connected to factory equipment. Control out is a simple output connected to other factory equipment. The signal from control in should be multiplied by 2 and copied to control out. I believe. Yeah, okay. So that one, don't have to worry about. We just need to multiply whatever value comes in by 2 and send it to control out. I like them going that way. I think that looks better. So basically, as I move, needs to move P0. Is that how you do it? Okay. Oh, and then do sleep 1. And then I believe it's multiply. Let's see. You do multiply again. I don't remember. I'll figure it out real quick. Multiply. Okay. Operation, command sequence. Didn't pass it, did I? I might have passed it on accident. Yes, I did. Those are the registers. Let's see, here it is. Multiply r/I, multiply the value of the first operand by the value. Okay, so I just need to do mul2. Then move ACC to P1. Move that sleep down here. It's going to move P0. Multiply it by 2 and move that there. Alright, I think it's working. Cool. Turn to email. Objective, win a game of solitaire. I think I can skip that one for now, because I'm not very good at solitaire, honestly. Pulse generator. In order to test some of our new manufacturing equipment, we need a pulse generator with certain requirements. We could simply create our own. You're right. Button is the simple input connected to a button. When the button is pushed, generate pulses as indicated in the verification tab. Okay. I think this one we need to use the check command. Check P0 equal to 100. Oh, well, first I gotta connect the pin. And if it is, then move 100 to P1. Sleep 1. Move 0 P1. Sleep 1. Otherwise, do nothing. Let's see. Oh, then I gotta put a sleep 1 at the end. Okay, well that seems to work. Very cool. I seem to have more lines of code though. Actually, I can make that better. I'll just that there. Does that work? Okay, that actually lowers my lines of code by 1. Much better. Turn that down a little bit. Sucks having my music all at inconsistent volume levels. I have to just change it all the time. I like this one because this one has like a little color or like LED picture, which is kind of cool. Right. Simple outputs connected to display segments corresponding to a clicking animation. I think I'll need at least 2 microcontrollers for this. Actually, are they all simple outputs? Does this give me... No, it doesn't. Let's see. Something like that. And work on that one first. So this one, these two just alternate. So it's pretty simple. It'll just be 100p0, move 0p1, sleep 1, move 0p0, move 100p1, sleep 1. That should... Okay, yeah, so that one's good. Alright. If there's any way to do that by combining them into one signal. I don't think so. Problem here is it only gives you, like, I'm gonna have to use 3 of these things. Alright, whatever. So drink 0. That seems to be a consistent alternation, so it's going to move 100 to P0. Sleep, looks like 6. Move 0, P0 for 4. Then I believe P1, not P0, not P1. That one works properly. And then... Is there a better way to do this one? Turn that up slightly. So move 0 to P1 after sleeping 6. Move 0, then move 100 to P1. enough lines of code, move 0 P1, sleep 1, might be better to combine that one, go there. That might be better. So move 100 P0, move 0 P1, sleep 6. That's a V, not a S. Move 0 P0, sleep 1, move 100 to P1, sleep 2, move 0, P1, sleep 1. Does that? Perfect. Exactly the amount of lines of code that I needed. And then for this one, it'll be move 0 P0, sleep 6, move 100 P0, sleep 1, move 0 P0, sleep 2, 100 P0, sleep 1. That should be it, I believe. Cool. Let's see what the lowest amount of lines of code is for that. I was at the average, I guess. Seems like you can get a lot less though. Oh well, I seem to be just about at the right place. I'll move on. I like Joe, he's funny. Oh yeah, this one, okay. Points and foul are simple inputs connected to buttons. Point is pushed, the count should be incremented by 1. Foul is pushed, the count should be decremented by 2, but not below 0. I think I'll definitely need at least that. This. So display can go to X bus. Perfect. So first it would need to move let's see. Let's see, how would I do this? Let's see, check less than okay, so it need to first check for the buttons being pressed, and then it would need to move some value to ACC. Then I'll store the total value in DAT. Let's see. Move P0, or no, P1. ACC. Is it add to that? Maybe? I guess when you add though, it automatically does that. Let me look at the information again. Counter should keep track of accounts starting at 0 and ensure that the display is always showing the current value. So I'm going to need to keep the total somewhere, either in ACC or DAT. Actually, can you just let me check what the TEQ things are. Okay, you can do it for a register, so I just need to check P1 is 100. If it is, add 1. Too quiet now. Okay, so it needs to add 1, and then otherwise check P0 is 100. If it is, sub 1. And then after all that, check ACC is less than 0. And then if it is, move 0 ACC, and at the end I need to move ACC to X3 and sleep 1. Let's see if that works. Checks if, let me reset that, so it's going to check if P1 is 100, which it's not. Check if P0 is 100, which it's not. It's going to check if ACC is less than 0, which it's not. It's going to move that 0 to X3, sleep. Then it's going to check if P1 is 100, which it's not, and P0 is 100. It's going to subtract 1, so you're going to get -1, which it checks and sets equal to 0 again. Just going to do that again. Okay, so now P1 should be 100. It's going to add 1. Oh, there's a mistake. Where were those again? Conditional execution, page 2? Not there. Oh, I think I saw it. Conditional execution, all instructions in the MC XXX programming language are capable of conditional execution. Prefixing an instruction with a plus or minus will cause that instruction to be enabled or disabled by test instructions. The instruction is disabled. Actually, I don't even need this subtraction there. Okay, that seems to fix it. Just... Nope, something went wrong there. Oh, what's that? Ah, thank you. Pause. Very much appreciated. I just decided to play some of this because I've taken a class this semester that's like basically this game as a class. I'm like, oh, this seems like a good thing to stream, I guess. Appreciate the host though. Alright. So something's going wrong there. So what is going wrong here? So it checks P1, checks P0. Oh, right, it's supposed to subtract 2. That's my problem, not 1. Is that it? Perfect. Alright, production cost. Looks like the best is around 3. Could you do that with a... Oh, right, I could just do that with this probably. Does it fit? Okay. P0 is the foul. Actually, I'll just move this again. And then I'll just need to change the X3 value to an X1. I believe that should fix it. That should lower the production cost to 3 instead of 5. Awesome. Rubbish audio thing. Audio in is a simple input. Audio out is a simple output. Maximize is a simple input. The signal from audio in... Why is this music so quiet? Signal from audio in should be copied to audio out, applying the harmonic maximization algorithm. Look at the supplemental data section. Let me find that. Supplemental data. So it'd be here. Audio out equals audio in minus 50 times 4 plus 50. So basically it needs to take I think I'll need 2 of these. And they'll need to be connected that way. Alright. Okay, so I think the first thing that'll need to happen is to check that whether P1 or no, P0 is equal to 100. If it is, actually, hold on. It needs to move P1 to ACC, check that value, and if it is, then it needs to, let me see what that equation was. Also, this is very loud. Okay, so first it does audio in minus 50, which audio in is P1, so it needs to do sub 50. And then I believe it's multiply by 40, then add 50, or multiply by 4, add 50, and then once that's all done, move ACC to X1, and then needs to move X1 to P1, or X0, sorry, not. Let's try that. Looks good. I think it's gonna work. Okay, so the lowest production cost was like 4. I'm not sure what these mean, because I'm fairly certain you can't do this in 5 lines of code. That just doesn't seem possible. I don't know. You brought a self-driving car. You may be entitled to financial compensation. If your loved one bought a car in the past 5 years that was self-driving, you may be entitled to financial compensation. Fantastic. Infrared sensor. Okay, let's just look at it. Time. Which one's time? Is that one of these? I did not mean to add that song to the playlist. Or that one. Wait, am I just... There we go. Let's do that song. That's a good song. Actually very much fits this game, I think. Anyway, okay, time is a simple input connected to a D2-2415 clock, providing the current time. Sensor, which is this one, is a simple output connected to a silent alarm. When the current time equals the on time, the device should be armed. When the current time equals the off time, the device should be disarmed. Whenever the device is armed and the sensor reads at or above a value of 20, the alarm output should be active. Device is armed. Sensor reads at or above a value of 20. Okay, the on and off times are set by the operator using dials that can be read as X-bus inputs and use numerical values compatible with DT2415. So at least this will be necessary. What does the RTC do? I'm gonna check that in my parts list. Is that this one? Yeah, that looks like it. Okay. DT2415 incremental clock emits a simple I/O signal that corresponds to the number of 15-minute increments since midnight. Let's see. Okay. Includes a built-in battery backup so that the time is kept even when power is not available. Time. Okay, so that would be this one, I guess. Yeah, it goes up to 95 and then it goes back down to 0. So this is time right here, even though it doesn't say it, it is. Sensor. What does it say about the on and off times? The on and off times are set by the operator using dials that can be read as X-bus inputs and use numerical values compatible. DT2415. And then sensor was a simple input. The thing I don't get is you can rotate this one, but you can't rotate like these. Like it'd be really nice to just have these X inputs swapped with the simple inputs. Can't do that unfortunately though. Always do it this way, I guess. Okay, just making sure those don't connect. Actually, do these... What am I thinking? I can just move these. Never mind. I'm dumb. These need to be like connected to this. Let me see what these different things mean. NC, I believe NC probably just means it doesn't do anything, and then time index. No. Not. Let's see, how do I do this one? I kind of don't really understand how these things work and how they relate to each other. This is time. So in the current time, 35. better. Sensor 93 and 38. 93. I accidentally add a lot more songs than I meant to. I remember adding half of these. Maybe I just added the wrong ones. So that one makes sense, because that one is when it's at 93. Which is the right on time, but then the off time is 38. What's it supposed to do? When the current time equals the off time, the device should be disarmed. Why is it armed here when value is 1? I'll figure this out. The on time doesn't change, does it? Nothing really happens here at 38, which is the weird thing. See, what's it say about the sensor again? The sensor reads at or above the value of 20. The alarm output should be active. Oh, I think I get it. Armed and active are different. Okay. So basically, once it passes 93, which is here, and this value is above 20, that's when it's supposed to be active. And then once it passes 38, it needs to go deactivate again. So like right here, it's not active. Okay, I get it. Okay, so sensor was a simple input. Time is a simple input. An alarm is a simple output. Oh boy. Add one of those, I guess, because I need more simple connections. Okay, so first it's going to check that P1, or no, check greater than P1 92. If it is, it should check greater than P0 20. If that is true, then it needs to move 100 to x2. And then that would need to move x0 to p1. And then otherwise it would need to move 0 to x2 and sleep 1. Let's simulate. Okay, it starts out fine. So it needs to check P1 is greater than 92, which it is, right? No, wait, it's not. Oh. Okay. I understand the problem now. I need to do something with 38. So the time needs to be past the 93. I have an idea. So we would need to check that P1 is equal to 93. Then if it is, move 100 to ACC, and then it would need to check P1 is equal to 38. If it is, move 0 to ACC. And then check ACC is equal to 100. If it is, check the sensor, which is P0, is greater than... Is it greater than 20 or greater than equal to 20? Okay, so greater than 19. And then if that is the case, then move 100 to x2. Now let's simulate. Screw up somewhere. Check P1. Move 0x2, is that what I need to do? Alright, I think that worked. At least it looks like it did. Oh, nope, it kind of did for a while. Until it got to here, where value in ACC is 0. So why should the alarm be sounded? Because oh, these values change. Gotcha. I understand now, so I need to do a little bit more here. Alright, let's see, So I need to check. Let's change this up a little bit now. Check that P1 is equal to X0. If it is, move 100. Then check P1 is equal to X1. If it is, then move 0 ACC. And check ACC equal to 100. If it is, then move 100 to X2. Otherwise, move 0 X2. Let's try this. Oh, duh, it's gotta check that, sensor, which is P0. So, P0 is greater than 19. There we go. Okay. Come on. Nice. Oh, and I got less power usage than the highest, or like average. That's pretty good. It says the best line of codes is 9 though, and the best production cost is 6. So if I had 6, that would mean I would basically just need to use two small microcontrollers, NC4000s. I'll have to see if I can do that. I might be able to actually, because right now I'm using, I guess. Okay, and then power usage. Can I fit all of this code into one of the smaller ones? Can. Okay. And also, what's the difference between these? So it costs the same. One has an X next to it. I'm gonna check and see what the difference between these two are. MC4000. Nine lines, 2 X bus, 2 simple, 1 general purpose register. As a result of customer feedback, an X bus only variant will be made available this year. Oh, did I put the wrong one out? Okay, alright, that one only has X bus. I get it now. Alright, would I be able to do this though? Because I don't think I have enough pins. Right? Or could I somehow use more pins on this one? I think first off, I'm gonna just add a new design. See if I can do this using only these. Okay, so let's try putting these right next to each other. Okay, and then okay, can I make this work? Well, no, because I need to output a value from here to there. So I need to leave one of these X buses open. Hold on, let's see if I can do this. Somehow move value x1 to x1, and then read x1 and move that to ACC. And if I have x1 in ACC, then I can compare. I believe I can do that. Let's see, move x1, or move x, is that x2? x0, okay. Move x0 to x1. And then move x1 to ACC. Or no, I wouldn't even need to do that, would I? I just check P1 equal to x1, and if that is true, then move 100 to ACC, and check P1 is equal to x0. If that is the case, move 0 to ACC, then check ACC is equal to 100. If it is, check that P0 is greater than 19. If it is, move 100 to x1. Let's see, so do a step thing here. Somehow need this to be before. I'll work on this again next time, but for now I think I'm going to end the stream because I need to go soon. Thanks for watching though, and thanks again to Pause for the host. Very much appreciated.